Alright, so there are, well, 5 angles, I guess you could say, when we do the trigonometric ratios that give us essentially perfect numbers, okay? And we get these from 2 particular triangles. So what we're going to do is we're going to have a look at these special triangles and we're going to apply some Pythagoras theorem to them. And then look at the trigonometric ratios in relation to that. So we'll start off with the simple one, okay? So we'll take a right angle triangle. I love right angle triangles. So right angle triangle like this. Okay, I'm going to call this length 1 and this length 1. These 2 lengths are exactly the same. Now, if you do Pythagoras' theorem, and I actually implore you to stop and actually have a go, but if you do Pythagoras' theorem, you get that this side here is a square root of 2, because it's 1 squared plus 1 squared and the square root of that. So 1 plus 1 is 2, square root of 2. Now, what are the other corners equal to? Well, we know this is an isosceles triangle, so this triangle here must be equal to 45 degrees, and this angle must also be equal to 45 degrees down there. Okay, so we've got 2 angles that are equal to 45 degrees. Now from here we can actually write out our trigonometric ratios, sine, cosine, and tan of 45 degrees. And now it doesn't matter which 45 degrees you pick, because both the sides are going to be the same. So have a look at this. So we've got, alright, sine of 45 degrees. Okay. So go back up here, SOHCAHTOA. SOHCAHTOA, it always comes up, SOHCAHTOA. Okay, so sine opposite over hypotenuse. So it doesn't matter which 45 I pick. Let's say I pick this one down here. Okay, so my opposite is 1, my hypotenuse is root 2. That's 1 over the square root of 2. And if you were to rationalize this, so multiply the top and the bottom by root 2, you would get, Now let's do the same angle. So we're using this angle down here still. The cosine, so cosine of 45 degrees. Well, the cosine is the adjacent, which is 1, again, over hypotenuse, which is root 2. So which is also equal to 2 root 2. So what you notice is that actually these two are equal to each other, which is pretty cool. 45 degrees, sine and cosine are equal to each other. Now our final one we've got is tan. So if we do tan of 45 degrees, well, that's the opposite over the adjacent. So let's look at some of these values. The opposite is 1, the adjacent is 1. Get 1 over 1. And you'll notice it doesn't actually matter which side you use. So if I use this top end, the opposite is 1 again, and the adjacent is 1. Get the same value. And because that 1 is always on the top, okay, the value of that doesn't change which side you're using. So essentially what this means is that if I ask you to work out what tan of 45 degrees is equal to, you should be able to say, well, that's just equal to 1. Okay? If I was to say, well, okay, well, what's sine of 45 degrees equal to? Well, you should be able to say, okay, well, that's just equal to the square root of 2 on 2, or 1 over root 2. Okay? And these are the values. These are called the exact values, or the exact ratios. And these are numbers that you just have to remember. Or you remember the triangle and you get them that way. Now, as I said, there was 3 values that we could actually get that we know how to do that we could do this for. And the triangle for the second one's a little bit different. Okay? So the way that we get this second triangle, is let's start off with an equilateral triangle. Now, you might be saying, well, sir, I know, because I'm a genie, that an equilateral triangle, well, that's not one to begin with, but an equilateral triangle, it doesn't have any, doesn't have a right angle in it, so we can't actually do Pythagoras' theorem on it. Correct, we can't actually do Pythagoras' theorem on a triangle. So what we're going to do instead is we're actually going to break it in half. We're going to cut it down the center like this. Now, my equilateral triangle, okay, because it's an equilateral triangle, I'm going to make the sides equal to 2. Okay, so every side is equal to 2. And so if I split it in half like this, okay, let me draw the half I'm going to use. I'll use this half, okay. Use this half like this. Okay, so, well, this side stays the same, and we've got this right angle down here now. So by cutting this equilateral triangle in half, okay, straight up the middle, okay, I'll get a right angle. So I know that side there is equal to 2, but what's this bottom side equal to here? What's this length along here equal to? Well, if we go back to our original equilateral triangle, okay, well, if it's 2 all the way across, and I've cut it halfway through, well, then this side must be equal to 1. So that side there must be equal to 1. Now, we need to use the reverse of Pythagoras' theorem, so have a go at it. Pause the video and have a go and see if you can work it out, but for those who want to just get through it quickly, 4 squared minus 1 squared equal to the square root of, well, sorry, not 4 squared, it's 2 squared. Jumping on too quickly there. So square root of 2 squared minus 1 squared, and of course that's going to be equal to 4 minus 1, so it's equal to the square root of 3, okay? So that's just using Pythagoras' theorem. So that's the c squared equals a squared plus b squared. And because we knew what the hypotenuse was in this one, okay, we know what the hypotenuse is in this one, so we have to work out what the other two are going to be. Alright, so now that we've got this triangle, well, what else do we know about the original equilateral triangle that we started with? What did we know about this guy? Well, if it's an equilateral triangle, then every single angle in here is equal to 60 degrees. That's to be, because it's equilateral. They've got all the same things. Okay, so if I go over to this triangle here, well, that means that this angle in here must be equal to 60 degrees. And then what about this angle in here? Okay, what's this angle in here equal to? Well, again, I've chopped it straight up the center. Okay, so if I've chopped the angle in half as well, and it's a 60 degree angle, then I must have half on either side. So what that means for us is that, well, in this corner here, we've got 30 degrees. Okay? And so 60 and 30 degrees are the other 3 trigonometric ratios we're going to be looking at. Okay? So we've got the sine ones, the 45 ones up here. Now we're going to look at the ones for 30 and 60. Okay? So let's have a look. We'll start with the 30 degrees on that side, and then we'll do the these ones, the 60s on the side here. Okay, so from here, let's work out what these ratios are. So I'm using this triangle over on this side now, so this 30-60 triangle. Remember, these are values that you just need to remember, so we'll write them up in a nice little table as well. Okay? So 30 degrees, we're starting with sine. Okay, so it's opposite over hypotenuse, so 1 over 2. And that's it, and that's exactly what the answer is. If I put sine of 30 degrees into my calculator, sine 1 over 2, here equals, look at that, we get, whoops, if I do the, sine of 30 degrees in the calculator, if I put sine of 30 degrees in the calculator, it equals, I get a half. Look at that, perfect. Exact same answer. Now cosine, okay, cosine you can't test with a calculator because, well, we've got a square root for this one, so opposite for this one is the square root of 3. Sorry, I'm doing 30 degrees, aren't I, not 60. The adjacent is 30 degrees, the hypotenuse is 2. So we write it as the square root of 3 on 2. And we leave it like this. Do not write as a decimal. You will lose marks. Okay, this is the exact form. We need it, leave it in exact notation. It's exactly the square root of 3 on 2. Okay? You write down, if you put in cos 60 into your calculator, it tells you to put an exact answer. Oh, why do I keep getting this wrong? Cos 30 into your calculator. Okay, my calculator is square root of 3 on 2, but yours might just give you this. If yours does that and you write that in there, okay, you might get the answer wrong. You leave it as a square root. Alright, and finally tan. So tan is opposite over adjacent. My opposite is 1. My adjacent is root 3, so it's 1 over root 3. Or we can rewrite that as root 3 over 3 if I rationalize the denominator. So that's by timesing the bottom and the top by the square root of 3. Okay, which you are allowed to do. Okay? And again, just like with the cos of 30, Do not write this as a decimal. If you write as a decimal, we will hunt you down and we will tell you not to do that again. Okay, being a very naughty boy or girl, or non-binary. Now, for the 60 degrees, okay, same deal, but from the other corner. Let's start with the opposite. We've got the square root of 3 and the hypotenuse, which is 2. We write square root of 3 over 2. And you might notice that the square root of 3 over 2 looks an awful lot like the cos of 30 degrees. And that's because these two guys are the same value, okay? Because if I add 60 and 30 degrees together, what do I get? Well, we get the 90 degrees. So that means that these two angles are complementary. And the complementary angles for sine and cosine should be the same thing. Okay? That's what sine and cosine means. If you notice, okay, sine to cosine, okay? Cosine is the complement sine. That's actually what cosine means, the complement of sine. Okay? So if it's the complement of sine, okay, and remember, think back to geometry, complement, talking 90 degrees, okay? If they add up to 90 degrees, the sine and the cosine, okay, they should be the same thing. Because that's how it works. Right, so from that explanation, you should be able to work out what the cos of 60 is going to be. But we'll use the diagram to do it. So cos of 60, okay, adjacent over hypotenuse, 1 over 2. Done, perfect. Easy, okay? And again, you'll notice that that's exactly the same as that one there, okay? These two are the same as well because it's complement to each other. Okay, they add up to 90 degrees. Okay, the sine and the complement of sine are equal to each other. For the same, for the 90 degree angles. Okay, and finally tan. Okay, we've got opposite over adjacent. So opposite is root 3, adjacent is 1. Right, root 3 over 1, which is just equal to square root of 3. Okay, and that's it. So what I'm going to quickly do is I'm just going to show you this thing that I've got here. Okay, and I'm going to make it bigger for you guys to actually see. Okay, so the thing I want to basically say is that what you're going to be answering today, or in this lesson, is essentially questions like this. Find the exact value of the following. Okay, cos of 60 degrees, sine of 150 degrees, and tan of 135 degrees. Okay, in fact, actually, let's do those. Let's actually work out what those are. Okay, so examples. Okay, 1, find in exact form. Okay, we've got number A, cos of 60 degrees. Or B, sine of 150 degrees. C, tan of 135. Okay. Now, we have to use part of our previous lesson to do this. Okay, that's where we looked at the obtuse angles. This is why this stuff follows the obtuse angles. So cos of 60 degrees, okay, if we go back up to here and have a look, cos of 60 degrees, well, that's just equal to a half, okay? So this one is just equal to a half. That's nice and easy. Okay, we're happy with that one. Now, sine of 150 degrees, okay? So this is where we've got to go back to our previous lesson. I'm going to quickly go back up to this thing up here that we did a while ago, okay? And in fact, I'm only going to look at the formulas. Supplementary rules. Okay? My supplementary rule says, and I'm looking at, the one I'm looking at is this one here. Okay? So sine of 180 degrees minus theta is equal to sine of theta. Okay? So let me write that down here. So my rule is sine of 180 minus theta equals positive sine of theta, okay? It's important it's positive. So, what value of theta do I need to subtract to get to 150? Well, has to be 30 degrees, okay? So therefore, theta equals 30 degrees, okay? Because 180 minus 30 is equal to 150, okay? Because I need to work out 180 minus what got me that. Okay, so that's a supplementary angle. Okay, now from here, we know that sine 30 degrees equals sine 150 degrees. So if I know what sine 30 degrees is, I know what sine 150 degrees is. So sine 30 degrees, okay, well what's sine 30 degrees equal to? Let's go back up and have a look. Oh, well that's easy, it's a half as well. Sine 30 degrees is equal to a half. So therefore, sine of 150 degrees is also equal to a half, okay? Because they're both the same, they're supplementary to each other. Sine 30 is supplementary to sine 150, okay? Right, now, if you didn't quite get that one, that's fine. We're going to practice doing another one of those. Okay? And we're going to practice it with this tan. And we'll do this one in red. Okay, tan 135 degrees. Let's go up and look at the rules. Okay, the tan one I'm using is this one. Okay, the tan rule says tan of 180 minus theta equals negative tan theta. Okay, negative tan theta, so let's write that down. Tan of 180 minus theta is equal to negative tan of theta. Okay, so if I can work out what number I'm subtracting, okay, this should all fall into place. So tan of 180 minus, okay, what number do I need to minus to get to 135? Okay, what number do I need to take away to get to 135? Well, it's going to be 45 degrees. Okay, as a general rule of thumb, it's either going to be 30, 45, or 60. Okay, it's not going to be anything else. So tan of 135 degrees, so theta in this case is equal to 45 degrees, okay? Because that's the number that we had to take away. So that's the number we found in there. Okay, so we know that tan of or minus tan of 45 degrees. Actually, we'll write it this way around, I think. Tan of 135 degrees is equal to minus tan of 45 degrees, okay? So whatever tan of 135 degrees is, it is equal to minus tan 45. So if I work out what tan of 45 is, I can then do the minus of that, okay? So let's go up and have a look. Tan of 45, okay, it's not these ones. Tan of 45, well, 1 over 1, which is just equal to 1. Okay, that's easy. So it's minus 1. So that's my answer, minus 1. So therefore, tan of 135 degrees is equal to minus 1. And if you're not sure of that either, grab your calculator and check. Okay, tan of 135, close it off, hit equals, look at that, minus 1. So you can actually use your calculator for this too, if you're not 100% sure what to do. Okay, the only thing is you have to keep in mind that when you've got these exact values, okay, and I wanted to do, say, something like this, let's say 150, okay, so my one gives me negative root 3 on 3, but yours might give you that, and you might not be might be quite sure what that is, okay. But as long as you know what number you're taking away from that, so in this case we're taking away 30, okay, then you just go back up, okay, and you say, okay, well which tan of 30, what's that equal to? Okay, that was the root 3 on 3 one, okay? So that's pretty much it, okay? And that's pretty much all we need to do for this one, guys. There's going to be a worksheet for you, and I'll leave it to you.